Welcome back, YouTubers. Uncle Pythagoras signing in. Thank you very much for those who have subscribed, who have liked and shared the videos. Today we are going to talk about Paper 2 Physical Sciences, which is chemistry. We are going to take the question from Limpopo, September 2023. Question 5.3. We're going to do question 5.3. Right, the question reads as follows. A teacher uses the reaction between magnesium ribon, MgS, and nitric acid, HNO3 aqueous, to investigate one of the factors that influence reaction rate. The balanced equation of the reaction between magnesium and nitric acid is given below. This is the balanced equation. This is the equation. This is the balance equation of the reaction. Right, the question that follows says that 5.3.1. Write down an investigative question for this investigation for 3 marks. They want us to write down for 3 marks. Write down the investigative question for this reaction. What could it be? They want us to say what is happening to this reaction. So the investigative question follows. How will a change of concentration affect the reaction? This is the question that you need to write. How will a change of concentration affect the reaction rate? This is how you answer that question. Coming to question number the result obtained when using diluted nitric acid are shown on the graph below. They are going to give you the graph. This is the kind of graph they will give you. Let's say you are given this graph. This is the amount of magnesium it is in moles, and then here you have the time in second. Now they give you that this reaction is going to start at 1 mole, 1,0 moles. It starts our graph going steeper and steeper. at 0,8. This is 0,8 moles. This is what will happen, and that will take time at 30 seconds. Right, you are given a graph like that, then the question asks you which compound now the question read as follows: which compound, Mg or HN3, which compound? Mg or HNO3 is in excess. Give a reason for your answer using the information on the graph. Now we are given this reaction. This reaction, it reacts with magnesium and nitric acid. This is happening. Then they say they want to know, according to the graph, which compound, magnesium or nitric acid, is in excess. What do they mean when they say in excess? They mean if you are using two of the chemicals, you are using them, and then which one is going to be a limiting reagent? Which one is going to be a limiting reagent and which one is going to be an excessive reagent? Then you check your equation. You check your equation. This equation happens if you dip in the solid strip of magnesium inside the nitric acid. As the time goes by, you will see that the amount of magnesium, you see it was at 0 seconds. It is at 1 mole. Then as after 30 seconds, it is at 0,8 moles. You see, as time goes by, this thing decreases. So it means that this amount of magnesium is going to decrease up until it disappears completely inside the nitric acid. So you are answering this according to the graph. The graph says nitric acid is used up completely. Therefore, this magnesium strip is the limiting reagent. What do we mean by limiting reagent? It means that if you put it inside the beaker like this, then you dip in the magnesium strip. After some time, this is going to react completely with this, with HNO3. So it is going to be used up completely. It is disappearing inside this liquid. Then this is in excess. This is a limiting agent. So as you can see that HNO3 is going to happen in excess. It means it is in abundant. It is more of it, more than this. It is in excess. Then this Mg strip is going to be a limiting reagent. This is what they want. And the graph, you can see it here. The amount of magnesium decreases as the time progresses. So it means that this is the one that happen in a small amount. It is a limiting agent. So it is going to say that then this inside the beaker is going to be in excess. The thing that happened in bulk, too much of it, is going to be used. Going forward to answer the next question. The next question is 5.3.2. We're going to do 5.3.3. They say calculate the average reaction rate in grams per second during the first 30 seconds. They want us to calculate the average reaction rate. The reaction rate calculate the reaction rate during the first during the first 30 seconds. Now this is what we need to calculate. So in order for us to calculate this, in order for us to calculate this in the first second, we are going to consider the following. We have the formula that says N equals to M over M, where M is the mass in grams. This is relative formula mass. Relative formula mass. It is in grams per mole. Right, now we know that at some point we are given that N is equals to the number of moles if you come, everything is given here on the board. Here we are given that we start the reaction with 1 moles of magnesium, and N is equals to 1. Then we say N is M over capital letter M. We started with what? With 1 mole. We say 1 is equals to relative mass. We don't know this. The mass of this object, of this magnesium strip, we don't know how much of it we have used, but the relative atomic mass, if you go to the back of your page, you are going to find out that it is going to give you 24 grams per mole. 24 grams per mole. Then calculating here, we know that our mass is going to be 1 mole multiplied by 24 grams per mole. This is going to give us 24 grams. The moles and moles cancel. We have 24 grams of magnesium of Mg. We come back again. We were calculating it from here. Now we calculate from here. We say that N is equals to 0.8 moles. We have calculated that N is 1 mole. Now we need to calculate at N is 0.8 moles. We calculated the grams here. Now we calculate the grams here. We say that N equals to M over M, the capital letter M. Now we will have a 0.8 moles of magnesium is equals to the unknown over relative atomic mass, which is 24 grams per mole. Now to find M, we multiply a 0.8 moles. You multiply that to 24 grams per mole. Multiply that by 24 grams per mole. Right? Right, according to the calculator, if you punch your calculator correctly, it is going to give you a 0.8. Multiply that to a 24. It is going to give you a 19.2 grams of magnesium. See, we started at 24 grams of magnesium was used when it was a 24 grams. We find it when it was at 0 seconds. Before it reacts, we have magnesium of 24 grams. After it has reacted for 30 seconds, after 30 seconds, now we have magnesium of 19.2 grams. How much of the magnesium has been used? So so to calculate, to answer their question, they say the reacting rate. The reaction rate is equals to the change of mass divided by the change of time. The change of mass, we know that we started at 24 grams, we ended up at 19.2 grams over a period of what? A period of time. It was 0 seconds, we went to 3 seconds. Now we have a 0.16 grams per second. This is the rate of reaction. We have a rate of reaction. So this is to answer question 5.3.3. Someone can say, how about you can use it differently? This is the up part. You can say the change in number of moles is equals to, it was 1 mole, subtract 0.8 moles. It was 1 mole, subtracted, we started at 1 mole, coming to 0.8 moles. So all that comes to give us that the delta M is going to be 0.2 moles. Now N is equals to M over M. This M is the grams, the mass, then this is the relative atomic mass of the magnesium. Remember, we're talking about magnesium. So in order for us to get that, we're going to say M is equals to N times M. We have calculated N to be a 0.2 moles. We multiply it with a 24 grams per moles. 24 grams per mole. When you calculate all that, you're going to get a 4.8 grams. This is the mass of the Mg used. Then the rate of reaction let's say rate of reaction is going to be delta M with the delta T, divided by delta T as the time progresses. Then it is going to be 4.8 grams, which we have calculated here. You divide it by 3 seconds, which is the time taken for the reaction to take place, is 30 seconds. When you multiply that in your calculator, you're going to get a 0.16 grams per second. This is another way of doing it. And then we go for going for the next question, which is okay. We are going to complete this. We are going to come and calculate back from 5.3.4. Copy the above graph in your answer book on the same set of axes. Use a dotted line. This is 5.4. 5.3.4. Now they want us, we can do it on this graph to show you what is happening. If we have used concentrated nitric acid, here it was a dilute, now we have a concentrated nitric acid that we use. We start here, this is concentrated, come here. This is how your graph will look like, because the graph becomes steeper and steeper, because the more concentration is, the more magnesium is going to be used at a faster rate. If you can check, your 0.8 grams will be here before 30 seconds. Now this is how you have answered the question. Thank you very much. Until we see each other next video. YouTubers, please do not forget to like, subscribe and share the video. Thank you very much. Have a great day.